Tonight, we're going to explore one of the most unsettling truths in all of science. A truth that quietly defies almost everything your body believes right now. Wherever you're lying, there is a direction you would call up. It's above your head. It's where the ceiling is, where the sky is, where you'd point if someone asked you which way the stars are. You have trusted that direction your entire life. You trusted it as a child reaching for something on a high shelf. You trust it now, without a single thought, as you rest. But up is not real, not the way you think it is. There is no up written into the universe. There is no arrow out in space pointing the way. What you call up is a small, local, borrowed thing, a habit your body learned from the pull of one particular planet, and the moment you try to leave that planet and truly travel up out of everything, the direction dissolves in your hands. It bends, it betrays you. It leads you in a circle or into a wall of gravity so deep that no machine we have ever built could climb out of it in 1,000 human lifetimes. By the end of tonight, you're going to understand why going up, really up and out, may be the single most impossible journey in our solar system, and what that quietly tells us about where we actually are. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now let's begin. Let's start with your own body, because that is where up was born. Right now, without trying, you know which way is down. You could close your eyes and still point to the floor. Deep inside each of your ears, behind the part you can see, there are 3 tiny loops of fluid and a small chamber lined with fine hairs and grains of calcium, no larger than specks of dust. When you tilt your head, those grains shift, the hairs bend, and your brain reads the direction they fall. That is your sense of down. It is astonishingly old. A version of it exists in fish, in jellyfish, in creatures that swam these instincts into being more than 500 million years ago. Life learned down long before it learned eyes, or hands, or thought. And up was simply defined as the opposite. Up is where down is not. That is the whole definition. Up has never been a place. It has only ever been an escape from the floor. So hold that quietly for a moment, because it changes everything that follows. The up you trust is not a direction in space. It is a direction in gravity. It points directly away from the center of whatever massive object is holding you. Tonight, that object is the Earth. Up, for you, right now, points away from the core of a ball of rock and iron 8,000 miles across, spinning beneath you in the dark. Someone lying in bed on the other side of the planet at this same moment is calling a completely different direction up, a direction that from out in space points the opposite way to yours. You are both right. You are both pointing away from the same center. And that is the first crack in the idea. Up is not one direction. It is a different direction for every person. On every world, everywhere, there are as many ups as there are places to stand. For almost all of human history, we did not know this. We believed the opposite, and we believed it completely. More than 2,000 years ago, the philosopher Aristotle taught that up and down were woven into the very fabric of the cosmos, real, absolute directions, the same for everyone, everywhere. Heavy things fell, he said, because they were seeking their natural place at the centre of the world, and light things like fire rose because their natural place was above. Down was the centre of everything. Up was the heavens. For 2,000 years, nearly every thinking person who ever looked at the sky was certain that up was a fixed and sacred direction, built into creation itself. It took until Isaac Newton, only a few centuries ago, for humanity to finally understand the quiet, humbling truth that up is not sacred and not fixed, that it is only the direction away from whatever mass happens to be pulling you, and that it points a different way for every stone in the universe. We are among the very first humans in the whole long story of our kind to even know that up is not real. You are lying in the dark holding a piece of knowledge that Aristotle died without. And you can lose it. Astronauts discover this within hours of reaching orbit. Up there, falling endlessly, those little grains in the inner ear no longer settle in any direction. They float, weightless, sending the brain no signal at all. And the brain, starved of its oldest certainty, begins to grope. Some astronauts suddenly feel that the ceiling is the floor. Some cannot tell, with their eyes closed, which way their own arms are pointing. Many are quietly, deeply sick for the first days, their bodies in revolt against a world with no down. They have to choose an up, to simply decide that the wall with the labels on it is the floor, and hold to that decision by will alone, because the universe has stopped supplying one. That is how thin the thing you're resting on really is. Take away one planet's pull, and the most trusted direction of your entire life quietly evaporates. We think we understand this. We say it casually, sure, in space there's no up or down. But we've never really felt what it costs to act on it. Because the instant you try to go up and keep going, the universe starts charging you a price that rises faster than anything your mind is built to imagine. Tonight we're going to climb that ladder together, one rung at a time, and watch the price grow, from the tug of your own bed all the way to the edge of everything. Each step will be harder than the one before it, and by the top you'll see that the ladder doesn't actually have a top at all. Let's take the first real step. Chapter 1. The direction that falls back down. Imagine standing up. Just that. You rise from where you're resting, and for a moment you go up, a foot, maybe two. And then, gently, the universe takes it back. You settle. You come to rest a little higher than the floor, only because something solid is pushing back against the pull. Take that solid thing away, and you fall. Up on the surface of the earth is never free. It is always borrowed, and the loan is always called in. So we learn to throw things instead. A stone, a spear, an arrow. And every child discovers the same law the same way. Whatever goes up comes down. Throw harder and it goes higher, and it stays gone a little longer, but it always returns. For almost all of human history, that was simply what up meant. Up was the brief part of the arc before the falling. Nobody imagined you could throw something so hard it never came back. Because on Earth, at human strength, you can't. You would have to throw it at a speed that no arm, no bow, no cannon could reach. That speed has a number. It's called escape velocity. and for the Earth it is about 7 miles every second. Not 7 miles an hour, 7 miles in a single second. If you could throw a stone that fast, straight up, ignoring the air, it would rise and slow, but it would never quite stop, and it would never come back. It would coast away from the Earth forever, always getting a little farther, always slowing a little more, but never falling home. That is what it truly costs to go up off this one small world. 7 miles a second. About 25,000 miles an hour. Roughly 10 times faster than a rifle bullet leaving the barrel. And here is the first thing that should quietly astonish you. That enormous number, the speed that felt impossible for all of human history, is the easy part. It is the smallest rung on the ladder we're climbing tonight. It is the gentle first step. Everything after this will ask for more. Much, much more. Now, none of this is exaggerated, and I want you to trust that as we go. Every number tonight is real. Every one has been measured, or flown, or paid for with actual machines and actual fuel. We are not telling a story about what might be true. We are describing the shape of the place you actually live in. Think about what escape velocity really means, though, because it hides something strange. It doesn't say you need a certain force. It says you need a certain speed. A feather and a boulder need exactly the same 7 miles a second to leave the Earth for good. Gravity does not care how heavy you are. It cares only how fast you're moving away and how deep the well is beneath you. And the well beneath you, the Earth's gravity, is, on the scale of tonight, almost nothing at all. A shallow dimple. A puddle. We are going to find wells so deep that 7 miles a second wouldn't even ripple the surface. But before we leave the Earth behind, there's one more secret in that first rung, and it's the one that first breaks the meaning of the word up. Because when we finally did learn to throw things fast enough, we discovered that up doesn't take you away. Up curves. Up comes back, not by falling to the ground, but by falling around the whole world. And that quiet, beautiful betrayal is the next rung. Let me show you. Chapter 2. Why up becomes a circle. Here is a thought that took humanity thousands of years to have clearly, and it belongs to Isaac Newton, sitting with a simple picture in his mind. Imagine a cannon on top of an impossibly tall mountain, above the air, firing a cannonball sideways, straight out, parallel to the ground far below. Fire it gently, and the ball arcs out and falls, landing some distance away. That's an arrow's flight. Fire it harder, and it travels farther before it falls, curving down to meet a ground that is itself curving away beneath it, because the Earth is round. Now fire it harder still. And here is the strange and gorgeous moment. If you fire it fast enough, about 5 miles a second, sideways, the ball falls toward the Earth at exactly the rate the Earth's surface curves away from it. It is always falling. It never stops falling. But the ground it's falling toward keeps bending out of the way, so it never lands. It falls forever, around and around, in a circle. That is an orbit. That is all an orbit has ever been, not a thing held up in space. A thing endlessly falling and endlessly missing the ground. For a long time this was only a picture in Newton's mind. he had no way to fire anything that fast. It stayed a thought experiment for nearly 300 years. And then, one autumn night in 1957, humanity finally threw something sideways hard enough. A small metal sphere with 4 trailing antennas, launched from a desert, reached that magic speed of about 5 miles a second and began to fall around the Earth without ever landing. The first object we ever placed into that endless curve. People stood in their yards in the dark and watched a point of light cross the sky. Over and over, once every 90-odd minutes. And many of them wept, because for the first time in the whole story of life on this planet, something we had made was up there, falling and missing, refusing to come down. Newton's cannonball had finally been fired. And notice what it took. Not a way to hold something up, which is impossible, but a way to make it fall sideways so fast it never arrives. Every single thing we have ever put in orbit since, every satellite that carries your voice and your maps and your weather, is doing exactly only that. None of them rest. They fall forever at 5 miles a second, and we have simply learned to call that endless falling a home. And that is where Up quietly dies for the first time, because when we finally built machines that could go up, real rockets reaching real space, we found that they cannot simply go up and stay. Anything you lift straight up and let go will fall straight back down, space or no space. There is no shelf up there to rest on. The only way to stay above the Earth is to stop going up and start going sideways, fast, to convert your climb into that endless falling around. Everything you have ever seen in orbit, every satellite, every space station, every astronaut who ever floated past a window smiling, is not up there in any restful sense. They are all falling. Right now, tonight, the International Space Station is falling toward the Earth at 5 miles every second, and missing, and falling, and missing, looping the whole planet once every 90 minutes. The astronauts inside float not because they've escaped gravity. Gravity up there is nearly as strong as it is under your bed, but because they and their ship are falling together at exactly the same rate, in the same long curve. You have felt a whisper of what they feel, though you may never have named it. That small lift in your stomach when an elevator starts down too fast. The weightless instant at the top of a roller coaster just before the plunge. The drop of a car over a sudden hill. In each of those moments, for half a second, you and whatever you're sitting in are falling together at the same rate, and your inner ear loses its grip on down, and your stomach floats. That half second of lightness is not the absence of gravity. It is gravity pulling you and your seat downward in perfect step, so that for one breath nothing pushes up on you and you feel like you're flying. An astronaut in orbit lives inside that half second forever. That floating is not freedom from the Earth's pull. It is the endless, unbroken experience of falling toward it and never landing. We named it weightlessness, but the truer word is simply falling. A fall with no floor at the end, going around and around instead of down. And it does not matter how high you go, the falling never becomes rest. There is a special orbit, 22,000 miles up, far above the space station, where a satellite circles the Earth in exactly 1 day. so that it turns at the same rate the Earth turns beneath it and appears to hang motionless over a single point on the ground. Every satellite that carries a television signal sits up there, seeming to float, fixed and still above the equator. And even it is falling. It only looks still because its endless fall is perfectly matched to the spin of the world below. There is no height, anywhere, at any distance, where up finally gives you a place to simply stop and stay. From the space station to the farthest satellite to the moon itself, everything that is up is falling. The only things that ever truly stop are the things that come back down. Sit with that, softly, for a moment. The people we send up do not get to stay up. They get to fall in a very particular, very fast circle, and we call that staying. Up did not give them a place to be. It gave them a loop. And to hold that loop, they paid the price of the first rung, that's 7 miles a second, and then they simply keep paying it, forever, because the moment they slow down, the falling stops being a circle and becomes a plunge. The station has to be nudged higher every so often, because even at its height, a whisper of the Earth's air still drags on it, stealing its speed, trying to pull the loop back down into the atmosphere. Left alone, untended, it would spiral in and burn. Even up there, up is a debt you keep paying just to stay in place. So think about where we are on the ladder. We wanted to go up. We found that going up off the Earth costs a speed that felt impossible for all of history. And then we found that even after paying it, we don't actually get up. We get a circle, a fall dressed as a rest, a loop we have to feed forever or lose. And we are still, tonight, only inches off the ground. The Earth is still enormous beneath us, filling half the sky. We have not gone up in any way that would matter to the solar system. We have barely lifted our feet, because there's a far deeper floor beneath this one. The Earth is not the thing truly holding you. The Earth is just the small thing you're standing on, and it too is falling around something vastly heavier, in a well so much deeper that the Earth's own pull is a rounding error inside it. That deeper well is the next rung, and it is where the price of up stops being large and starts becoming almost unpayable. Let me take you down to the real floor so you can feel how far up would actually have to go. Chapter 3. The bottom of the well is the sun. Step back from the Earth in your mind. Let it shrink beneath you until it's a blue point, and look at where it sits. The Earth is not resting anywhere. It is falling, the same endless falling around we just watched, but on a scale that dwarfs everything. The Earth is in orbit around the Sun, moving not at 5 miles a second, but at about 18.5 miles every second, roughly 67,000 miles an hour, and it has never once slowed down, not in 4.5 billion years. You are on that ride right now. Everyone you have ever known lived and died on a world falling around the sun at 18 miles a second, and not one of them felt it, because there is nothing to feel it against. We are all falling together so smoothly that it feels like stillness. And the reason we're falling so fast is the reason this rung is so cruel. The sun's gravity well is deep, almost unimaginably deep. Nearly all the mass in the entire solar system, everything, every planet, every moon, every asteroid and comet combined, adds up to less than 1/50th of the Sun. Put another way, the Sun is more than 99 8/10% of everything here. It is not the centre of the solar system the way a king is the centre of a court. It is the centre the way the ocean is the centre of a single drop of spray. The planets are not partners of the Sun. They are almost nothing, flung around the edge of a well so deep we can barely see its bottom. So now ask the question again, the question of tonight. How do you go up? Truly up and out, from here. Not up off the earth, up out of the Sun's grip entirely, out of the solar system, into the open dark between the stars. What does that cost? To escape the Earth from where you're lying, you needed 7 miles a second. But to escape the Sun from way out here where the Earth orbits, you need to be moving at about 26 miles every second in the right direction. And you don't start from zero, you start with the Earth's own 18.5 miles a second already carrying you sideways around the Sun. So a probe leaving Earth can lean on that motion, can spend it like an inheritance. And still, it is brutally hard, because the Sun's well is so deep and so wide that climbing out of it means fighting a pull that reaches across billions of miles and never fully lets go. And notice something the well quietly forbids. Out here, you are not even allowed to stop. You cannot simply hang still in space at the Earth's distance and rest. If the Earth were somehow halted in its orbit tonight, its 18 miles a second taken away, left simply floating, it would not stay. It would begin to fall, straight toward the Sun, faster and faster, and in about 2 months it would arrive. The only thing keeping the Earth from plunging into the fire is that it is falling sideways fast enough to keep missing. Stillness out here is not rest. Stillness is a plunge that hasn't started yet. Every world in the solar system is racing at enormous speed for the simple reason that the alternative is to fall in. So when we talk about the cost of going up and out, remember that you don't begin from a standstill you could hold. You begin already sprinting sideways just to avoid the drop. And the climb up and away has to be bought on top of a sprint you can never stop running. We have built such probes, a small number of them, and their story is the truest measure of how hard up really is, once you mean it. In 1977, NASA launched 2 identical spacecraft, Voyager 1 and Voyager 2, and set them on a path to leave the solar system forever. To do it, they could not simply point up and fire. No rocket we can build carries enough fuel for that. Instead, they had to steal speed from the planets themselves, swinging close to Jupiter, to Saturn, letting the giant's gravity fling them faster, a trick called a gravity assist, borrowing momentum from worlds 1,000 times their size. Even with all of that, the most powerful rockets of the age, the slingshot of the largest planets in the solar system, the Voyagers are climbing out of the Sun's well so slowly that it has taken them more than 40 years to reach the edge, and they will drift for tens of thousands of years more before they pass anywhere near another star. This gravity assist is worth slowing down for, because it is the strangest tool in all of spaceflight, and it is very nearly the only reason we can go anywhere at all. When a small probe swings close behind a giant planet, it doesn't just get pulled along, it steals a sliver of the planet's own motion around the Sun. The planet, moving at tens of thousands of miles an hour in its orbit, drags the probe forward and flings it out ahead, faster than it arrived, as if the probe had grabbed the edge of a passing carousel and been whipped away. The energy comes from the planet's orbit itself. The probe speeds up enormously, and the planet, in exchange, slows in its own orbit by an amount so unimaginably tiny it could never be measured, because the planet is 1,000 billion times heavier. Voyager left Jupiter thousands of miles an hour faster than it came, and Jupiter paid for it by falling behind in its 4 billion year orbit by less than the width of an atom. That is very nearly the only way we have ever found to go fast in the deep solar system, not by burning fuel, which runs out almost at once, but by quietly robbing the momentum of worlds. And the 2 Voyagers were launched to do it in a way that will not be possible again for more than a century. In the late 1970s, the 4 giant outer planets, Jupiter, Saturn, Uranus and Neptune, happened to line up along one great curve on the same side of the Sun, an arrangement that comes around only about once every 176 years. That alignment meant a single probe could swing from one giant to the next, each one throwing it onward and outward. A chain of slingshots that would never come around again in any of our lifetimes. They called it the Grand Tour. The last time the planets lined up like that, it was the early 1800s, and no one alive could have used it. The next time will be far beyond the year 2150. We caught the one window in nearly 2 centuries, and we spent it flinging 2 small machines up the wall of the Sun as well as hard as the entire solar system could throw them. And that is what it takes just to go out, not even up, only out, from the shallow ledge where the Earth is parked. 40 years. That is how long our fastest, most determined attempt to go up and out has been climbing, and it has only just cleared the doorway. Think of how far that is from the child throwing a stone, watching it rise and fall in a single breath. We have thrown the stone as hard as our entire civilization can throw, using the planets as our arm, and after 4 decades, it is still coasting up the wall of the same well, slowing, always slowing, kept forever from falling back, only because we threw it just hard enough. And yet, and this is the quiet blow of this chapter, the Voyagers have not truly gone up at all. They went out. They travelled sideways and outward, along the great flat plain where all the planets ride, sliding along the surface of the well rather than climbing straight out of its throat. They took the easy direction, the cheap direction, the one the whole solar system is already moving in, because there is another direction, a direction almost nothing in the solar system ever goes. Straight up, out of the plane itself, up perpendicular to the great disk. And that direction, it turns out, is far more expensive than the one the Voyagers took. That is the next rung, and it's where the ladder starts to lean out over the abyss. Let me show you the shape of where we live, and why up out of it is a wall almost nothing has ever climbed. Chapter 4. The flatness you were never told about. Picture the solar system the way it's drawn for children, the sun in the middle, the planets circling it. Notice something about that picture that is so familiar you've stopped seeing it. The planets are all drawn on the same flat page, and that isn't an artist's shortcut. It's true. It is one of the most real and least felt facts about your home. The planets do not orbit the sun at every angle, like bees around a hive. They orbit in a disk. A vast, thin, flat sheet with the sun at its centre and nearly everything. All 8 planets, most of the moons, the asteroid belt, the rings of Saturn, lying within a few degrees of that same sheet. If you shrank the solar system to the width of a dinner plate, it would be thinner than the plate itself, thinner than a sheet of paper. We live inside a disk so flat it's almost a shadow. How flat is flat? 7 of the 8 planets orbit within about 7 degrees of the same plane. A tilt smaller than the hands of a clock make between one number and the next. Spread across the enormous width of the solar system, that near perfect flatness is astonishing. If you could stand back and see all the planets at once tracing their paths in light, they would very nearly draw themselves on a single sheet of glass. Not a swarm, not a cloud. A record, spinning, a single flat groove with the sun at the centre and everything we know riding around inside it. There's a reason for it, and the reason is beautiful. 4.5 billion years ago, before there were planets, the sun was born inside a great slow-spinning cloud of gas and dust. As the cloud collapsed and spun, it did what all spinning, collapsing things do. It flattened. A gentle rotation over millions of years pulls a shapeless cloud into a wide flat plate, the same way a spinning lump of dough stretches into a disk in a baker's hands. The planets formed later, from that plate, and they inherited its flatness. They were born lying down. They have been lying down ever since. That flat sheet has a name, the ecliptic, and everything you think of as the solar system rides within it. Now here is why this matters for going up. When the voyagers left, they left along the plane. They slid outward across the flat sheet, in the same general direction everything else is already moving, using the planets, which are all conveniently lined up in that same disk, to slingshot themselves faster. That is the cheap direction. The whole architecture of the solar system is arranged to help you go outward along the plate. But that is not up. Up, truly up, is perpendicular to the disk. It is straight out of the flat sheet, toward what you might call the top of the solar system, a direction where there are no planets to slingshot past, no helpful line of worlds, nothing but the sun's pull and the empty dark above the plate. And going that way is far, far harder. Because everything you inherited, the Earth's 18 miles a second, the convenient planets, all of it is moving sideways, within the sheet. None of it helps you climb out of it. To go up out of the plane, you have to fight your own inheritance. You have to cancel the very motion that the entire solar system handed you at birth, and then buy the climb on top of that, out of your own pocket, with fuel you don't have. We have tried it exactly once in a serious way, and the story is almost forgotten. In 1990, a small spacecraft named Ulysses was launched with a single strange ambition to fly over the poles of the sun. To do that, it had to leave the flat sheet entirely and loop up and over above the plane, to look down on the sun from the top. And there was no way to do it directly, not even close. There is no rocket that can simply turn 90 degrees and climb out of the ecliptic. The sideways speed you'd have to kill and the upward speed you'd have to buy are together beyond anything we can launch. So Ulysses did the only thing possible. It flew all the way out to Jupiter, the wrong direction, outward, away from the sun, purely so that Jupiter's immense gravity could grab it and hurl it up and out of the plane. It spent the largest planet in the solar system as a single tool, just to change its direction, just to go up. And even then, it didn't get high. Ulysses climbed out of the plane, yes, and swung over the sun's poles, and it was a triumph. But it remained bound to the sun forever, in a long, slow loop that carried it up and back down through the disk and up again. It never left. It could not leave. Going up even a little out of the flat sheet we live in cost us our largest planet as a slingshot and still ended in a leash. That is the fourth rung. We have been climbing all night, and we have finally managed once to lift ourselves off the flat plate of home, and we are still hopelessly held. Let the shape of that mission sink in, because it is one of the quiet proofs of everything tonight. Ulysses launched in 1990, carried up by the Space Shuttle Discovery, and then sent on toward Jupiter, away from the sun it wanted to study, out to the largest planet, arriving in early 1992. And at Jupiter it did the impossible thing. It let the giant's gravity bend its path almost 90 degrees, kicking it up and out of the flat plane entirely, tilting its orbit until it rode nearly over the sun's poles. No fuel we could carry could have done that. Only Jupiter, the biggest lever in the solar system, could throw a spacecraft that far out of the plane. And having spent Jupiter to buy that climb, Ulysses could do nothing more. It fell into a long, looping orbit that carried it up over one pole of the sun, back down through the plane, and up over the other, again and again, for 18 faithful years, until its power finally faded in 2009. 3 times it passed above the poles, 3 times it climbed, and 3 times the sun pulled it back down through the disk. It is still up there, silent now, still looping, still held, still unable to leave the neighborhood it spent a giant planet just to rise above. None of this is exaggerated. Ulysses was real, it flew for 18 years, and the reason it went to Jupiter to study the sun is exactly the reason tonight is called what it's called. Up is so expensive that to go up, you first have to go the wrong way, out to the biggest thing you can find, and beg it to throw you. But let's say you did it. Let's say you climbed up out of the plane and kept going, up past where any planet rides, up into the empty dark above the disk. You would think, surely, that now you're leaving, now you're truly getting out. And you would meet the next rung, which is the moment you discover that the solar system does not end where the planets end. It reaches out around you, invisible, for a distance so vast that everything we've talked about so far, the planets, the disk, the voyagers, turns out to be a tiny bright dot at the centre of something almost unimaginably larger. Let me take you to the first edge, the one Voyager finally reached, and then show you how far it still is from the true one. Chapter 5. The bubble you didn't know you were inside. The sun does more than shine. It breathes. From its surface, in every direction, it blows a thin, constant wind of particles. Pieces of broken atoms, flung outward at hundreds of miles a second, a steady gale of the sun's own substance streaming out into space. This is the solar wind, and it never stops. It has been blowing for 4.5 billion years, and it is blowing through the space around you right now, through the space around the Earth, out past the planets, filling the dark. And that wind carves a bubble. It pushes outward against the thin gas that drifts between the stars, the interstellar medium, and it holds that colder, stranger gas back, clearing a vast rounded space around the sun that belongs to the sun alone. That bubble has a name, the heliosphere. And you are inside it. Everything is inside it. Every human who has ever lived, every planet, every probe, the entire disk, all of it sits deep within this single enormous bubble blown by the sun's breath. You have spent your whole life inside the atmosphere of a star, and no one ever told you, because from in here you cannot see its walls. How big is the bubble? Here the numbers begin to leave the human world behind. The planets, all of them, are crowded into the innermost part of it. Neptune, the farthest planet, orbits about 2.8 billion miles from the sun. The wall of the bubble, the place where the solar wind finally loses its push and can hold the outside dark back no longer, is roughly 4 times farther still. About 11 billion miles out. It is called the heliopause, and it is, in one real sense, the edge of the sun's kingdom. Inside it, the sun's wind rules. Outside it, the wind of other stars, the gas of the wider galaxy, takes over. It is a shoreline, and crossing it is the closest thing there is to truly leaving. And the bubble is not a clean, simple sphere. It has an inner boundary too, deep inside it, where the solar wind first begins to feel the pushback of the outside dark and slows all at once, dropping in an instant from a supersonic gale to a churning turbulent drift. That inner shock front has a name, the termination shock, and Voyager 1 crossed it back in December of 2004, about 8 billion miles out. Beyond it lies a strange, thick, roiling region called the heliosheath, the outer skin of the bubble, where the sun's slowed wind piles up against the pressure of the galaxy, and Voyager spent years crossing just that skin before it ever reached the true wall. And the whole bubble is not round, but shaped a little like a comet or a windsock, because the sun is moving through the gas of the galaxy as it goes, so the bubble has a rounded nose on the leading side and a long soft tail streaming out behind. We are riding inside a vast luminous droplet, blown by our star, streaming through the dark. And even the nose of it, the near wall, is 11 billion miles away. We have crossed it. Once, with a machine that could report back. In August of 2012, 35 years after it launched, Voyager 1, that same probe flung out by Jupiter and Saturn, sailed through the heliopause and passed out of the sun's bubble into the space between the stars. We knew it had happened because the count of particles changed, the warm thin wind of the sun fell almost to nothing, and the colder, denser hum of the galaxy's own gas rose up around the little craft and did not fade. It had stepped through the outermost skin of everything the sun blows into the dark. We watched it happen in the data. The wind of the sun fell away behind it, and the colder, denser breath of the galaxy rose around it, and for the first time in the history of our species, something we had made was outside. Voyager 2 followed 6 years later, crossing in 2018 through a slightly different part of the shoreline, about 11 billion miles out. Take a breath and feel the weight of that. It took our fastest object, moving at over 38,000 miles an hour, 35 years of unbroken flight to reach the wall of the bubble. 35 years to cross a distance so large that the light of the sun, which reaches your window in 8 minutes, takes almost a full day to cross it. That is the edge Voyager reached. That is what we celebrated, and rightly so. It is the greatest voyage our hands have ever launched. And now, softly, the blow of this chapter, the one that resets the whole scale of the night. That edge, the heliopause 11 billion miles out, 35 years away, is not the edge of the sun's gravity. It is only the edge of the sun's wind. The bubble is where the sun stops pushing. It is nowhere near where the sun stops pulling. Voyager crossed out of the sun's breath, but it is still deep, deep inside the sun's grip, still falling, still held, still bound to circle back if it were somehow slowed. It did not escape the solar system, it escaped the sun's atmosphere. The gravity, the real chain, the thing tonight is about, reaches out around it 100 times farther than that shoreline, into a dark so vast that the heliopause, the edge that took 35 years to reach, is not even the doorway. It is a single step across the front porch. Let me show you how far the true well actually goes. Because when you see it, you'll understand that in the way that matters most, no human machine has ever left the solar system at all, and perhaps none ever will. Chapter 6. The well that reaches almost to the next star, far beyond the heliopause, far beyond where Voyager sails tonight. The sun's gravity keeps working. It gets weaker with distance, it always does, fading with the square of how far you go, but it never reaches zero. It just keeps reaching, thinner and thinner, holding fainter and fainter things in slower and slower orbits, out and out into the dark. And out there, held by that faint, far grip, is something almost nobody pictures when they think of the solar system. A shell. An enormous, ghostly, spherical shell of frozen worlds, wrapped all the way around the sun in every direction, at a distance that makes the planets look like they're sitting in the sun's lap. It's called the Oort cloud. It is where the long comets come from, the ones that fall in toward the sun once in thousands of years, blaze briefly in our sky, and fall away again for another age. And each of those comets is a piece of the Oort cloud that was nudged loose and sent tumbling inward. There may be trillions of them out there, frozen, silent, drifting, and here is the distance that should quietly take the floor out from under you. The planet's end a few billion miles out. The Oort cloud is thought to begin somewhere around 2 trillion miles from the sun, and to stretch outward from there to perhaps 9 trillion miles, or farther. In the units astronomers use for the deep dark, the outer Oort cloud may reach a light year and a half from the sun, nearly halfway to Proxima Centauri, the very nearest other star. No one has ever seen the Oort cloud. It is too far, too dark, too spread out, its frozen worlds too small and too distant to catch any light we could detect. We know it is there the way you know a shore is near from the shape of the waves. the long comets tell us. Every few years, one falls in toward the sun out of the deep dark, on an orbit so stretched that it takes thousands or tens of thousands of years to complete a single lap, and we trace its path backward and find it comes from far, far beyond the planets, from that vast surrounding shell. The great comet Hale-Bopp, which many people alive today remember hanging in the sky in the spring of 1997, came from out there and will not return for something like 2,500 years. And we have found a few worlds that never come in at all. A small frozen body called Sedna, discovered in 2003, loops the sun on an orbit that takes it billions of miles out and needs roughly 11,000 years to come round once. Sedna is thought to be one of the innermost members of that shell, and even it spends most of its enormous year out in a dark so complete the sun would look like little more than a bright star. Let that settle. The sun's gravity does not fade out somewhere past Neptune. It holds objects in orbit almost halfway to the next star in the galaxy. The true edge of the sun's kingdom, the place where its pull finally gives way to the pull of other stars, is not 11 billion miles away. It is more like 9 or 10 trillion miles away, close to 1,000 times farther than the shoreline Voyager took 35 years to reach. So do the arithmetic of the night, gently in your mind. Voyager 1, our fastest, our farthest, our finest, moving at over 10 miles every second, will take about 300 more years just to reach the inner edge of the Oort cloud, and then it will take roughly 30,000 years to cross it and come out the far side. 30,000 years. Longer than all of recorded history, many times over, folded into the crossing of a single shell of the single solar system we call small and knowable, and ours. When Voyager finally drifts out past the last frozen comet into the true dark between the stars, the pyramids will be 400 centuries gone, and whatever we have become, if we are anything, will have forgotten it was ever launched. And here is the softest, strangest part of it. As Voyager coasts through that dark tonight, more than 15 billion miles from home, the sun still has its hand on it. Every single second, the sun's gravity, faint now, stretched across an almost unthinkable gulf, still reaches out and tugs the little craft backward, ever so slightly slowing it down. Not enough to stop it, we threw it just hard enough that it will coast on forever. But it has never once been let go. In more than 40 years of flight, across more than 15 billion miles, through the wall of the bubble and out into the space between the stars, there has not been a single instant when the sun released it. The pull only fades, it never ends. The sun will still be holding Voyager gently 30,000 years from now as it drifts through the last of the frozen comets. Nothing we have ever made has escaped that hand. Nothing we know how to make ever will. That is the real size of the well we are trying to climb out of. That is what up actually means, once you follow it honestly. Not 7 miles a second. Not the wall of a bubble. A well so deep and so wide that our greatest attempt, after nearly 50 years of flight, has covered less than 1 part in 1,000 of the way to the top, and will need 30,000 years more just to clear the last of the sun's held and frozen children. And still, even this, even the whole vast well of the sun, reaching a light year and a half into the dark, is not the deepest flaw beneath you. Because the sun itself is falling. The entire solar system, well and bubble and disk and all, is being carried right now in a fall around something so much larger that the sun's whole 2-light-year kingdom is a single mote inside it. To go up out of that, out of the thing the sun itself orbits, is a rung so high that nothing we have ever built could climb even the first inch of it. That is where we go next. And it is where up stops being expensive and starts becoming, in any real sense, impossible. Let me lift you up one more level and show you the wheel that the sun is only a speck within. Chapter 7. The Wheel and the Impossible Climb Out of It. The sun is not still. We've said it a few times tonight, but now we follow it all the way up. The sun, carrying its planets and its bubble and its 2-light-year well of frozen comets, is itself falling, orbiting the centre of the Milky Way, our galaxy, in a great slow circle so wide that a single lap takes about 230 million years. The last time the sun was where it is now in that orbit, there were no flowers on the earth, and the first dinosaurs were just beginning. We have not completed one galactic year since. In the whole history of the human species, in the whole history of anything you could call an animal, the sun has not moved even a 50th of the way around this one enormous loop. And we are not near the centre of that wheel. We are far out toward the edge of it, about 26,000 light-years from the galaxy's heart, roughly halfway from the middle to the rim. A light-year is the distance light travels in a year, moving at the fastest speed the universe allows, and it is nearly 6 trillion miles. We are 26,000 of those from the centre. The light leaving the core of the galaxy tonight will not reach this arm of it until 26,000 years have passed, until long after everyone alive tonight, and their languages and their countries, are gone. That is only the distance to the middle of our own galaxy, one wheel among hundreds of billions. This is the scale we are about to try to climb out of. And it is not moving slowly. To hold that orbit, the sun is falling around the centre of the galaxy at about 143 miles every second. Not an hour. A second. You, lying in the dark, resting, are being carried around the heart of the Milky Way at 143 miles a second, and you feel nothing, because everything near you is falling with you, in the same smooth, silent curve, the way you feel nothing in a car moving at a steady speed on a perfect road. Now ask, one more time, the only question of tonight. How do you go up out of this? Not up off the earth, not out of the sun's well, up out of the galaxy itself, straight out of the great wheel into the true emptiness above it, the intergalactic dark. What does that cost? There is a smaller echo of this we can even trace in our own past. As the sun rides around the galaxy, it doesn't stay perfectly level in the wheel. It bobs, very gently, up and down through the galactic plane, rising a little above the disk and sinking a little below it, once every 30 million years or so, like a horse on a slow carousel. We are, right now, somewhere in one of those long, gentle rises. But even that bobbing never lifts us out of the wheel. It is a rocking within the disk, not an escape from it. Even the sun's own faint attempt to drift upward over tens of millions of years is caught and turned and pulled back down again and again for as long as the galaxy has turned. The galaxy, like the solar system, is mostly a disk, a flat wheel of a few 100 billion stars, 100,000 light years across and only about 1,000 light years thick. And once again, the direction we call up, the honest up, is straight out of the flat of the wheel, perpendicular to it, toward the empty space above the galactic plane. And once again, that is the expensive direction, the one almost nothing takes. The stars of the disk, the sun among them, all ride around within the wheel, sideways. Almost nothing climbs straight out. To climb out, you would need to reach the galaxy's escape velocity, the speed that lets you leave its gravity for good. Near the sun, that speed is around 340 miles every second. And here is the cruelty of it. The same cruelty we met with the ecliptic, now magnified beyond all meaning. The sun's own motion, that 143 miles a second, is sideways around the wheel. It does almost nothing to help you go up out of it. To leave the galaxy straight up, you would have to reach hundreds of miles a second in a direction the entire galaxy is not moving, out of your own pocket, with no planet and no star to slingshot you, because to slingshot off a star you'd have to reach it first, and the nearest one is 4 light years away. Put it in the terms of the machines we actually have. Voyager, our fastest, moves at about 10 miles a second. To climb out of the galaxy from here, you would need to be moving well over 30 times faster than Voyager, sustained, in the hardest possible direction, with a well beneath you not 2 light years deep, but tens of thousands of light years deep. Try to picture the climb even at the greatest speed the universe allows. Light itself, which crosses from the sun to your window in 8 minutes, which laps the entire Earth 7 times in a single second, would take about 1,000 years just to rise from where we sit up through the 1,000 light-year thickness of the disk and break out into the open dark above the galaxy. 1,000 years at the fastest speed that exists, only to clear the flat of the wheel. And to cross the wheel the other way, edge to edge, light needs 100,000 years. That is the size of the single galaxy we are trying to leave. Now remember that our fastest machine, Voyager, moves at barely 1 part in 20,000 of the speed of light. At Voyager's pace, simply rising up out of the disk, not leaving the galaxy, just clearing the thickness of it, would take longer than the Earth has existed. Not longer than history. Longer than the planet. We cannot do it. It is not that it would take a long time, the way the Oort cloud takes 30,000 years. It is that we have nothing, no rocket, no method, no dream on any drawing board that could even begin. If the sun's well was a climb of 30,000 years, the galaxy's well is a climb we cannot start. Up at this rung stops being a matter of patience. It becomes a wall with no first handhold. And yet the galaxy too is not the top. Because even the whole Milky Way, that wheel of hundreds of billions of stars, is falling, drifting through a still larger dark, pulled by still larger things. There is one more rung above this one. And it is the strangest of all, because at the top of the ladder, up stops being merely impossible to climb, and starts quietly to disappear, to lead nowhere at all no matter how fast you go. Let me take you to the last rung, the one where the universe itself takes the direction away. Chapter 8. The direction that runs away from you. Lift up out of the galaxy in your mind, impossible as it is, and look at where the Milky Way sits. It is not alone. It has a great companion, the Andromeda Galaxy, and a scattering of smaller ones, and together they form a small gathered family called the Local Group, a few dozen galaxies, held to one another by their own gravity, falling slowly around a shared centre, bound together for as long as the universe lasts. So there is one more well above the galaxies, the well of the whole Local Group. And to climb out of that, you would need speeds and energies that make leaving the galaxy look like standing up from a chair. But suppose, in the way of dreams, you could. Suppose you climbed up out of the Local Group and kept going up and out into the space between the great clusters of galaxies, the deepest dark there is. What would you find? You would find that up has finally betrayed you completely, because beyond the Local Group, the universe is not still, and it is not merely moving, it is expanding. Space itself, the empty distance between the galaxies, is stretching, growing, swelling in every direction at once, and it has been since the beginning. Every distant galaxy is rushing away from us, and the farther away it is, the faster it flees. Not because it is flying through space, but because the space between us and it is lengthening, everywhere, all the time. And in the last billions of years, that expansion has begun to accelerate, driven by something we can measure but cannot yet name, something we call dark energy for lack of anything truer, and it is pushing the galaxies apart faster and faster as time goes on. And the Local Group itself, that bound family of galaxies, is not sitting still in the middle of things either. It is being pulled, drifting at hundreds of miles a second toward a distant, enormous gathering of galaxies, drawn by the weight of thousands of galaxies piled together far across the dark. A pull so large and so mysterious that astronomers, before they could see what was causing it, simply called it the Great Attractor. Our whole galaxy, and Andromeda and all their small companions, are streaming that way together, part of a vast flat river of galaxies so large it has its own name, Laniatea, a word meaning immeasurable heaven. And even that titanic structure, hundreds of millions of light years wide, is only one feature in a universe scattered with them. There is no top even here. Every scale we climb to turns out to be falling toward a larger one. And above all of it, over everything, presides the strangest fact of the deep universe, the one that finally takes the direction away for good. Here is what that does to the idea of up. Pick a distant galaxy, high above the Local Group, and set out toward it at any speed you can imagine. 100 miles a second, 1,000, a fraction of the speed of light. For the nearest ones, you might in principle arrive, but past a certain distance, and it is not even that far. On the scale of the universe, the space between you and your destination is growing faster than you could ever cross it. The galaxy is receding faster than light, carried on the swelling of space itself, which is allowed to outrun light in a way nothing moving through space ever could. You could fly toward it forever, at the greatest speed the universe permits, and never gain a single mile. It would slip away faster than you close the gap, dimming, reddening, until its light itself could no longer reach you, and then it would be gone, not destroyed, just forever beyond, on the far side of a horizon you cannot cross no matter what you do. That is the top of the ladder. That is where up finally ends. Not at a wall you're too weak to climb. We passed that at the galaxy. Here, at the largest scale, up leads to places that are running away from you faster than you can ever chase, being carried off by the growing of space itself, until most of the universe has already crossed a line beyond which nothing we ever do, no ship, no signal, no dream, can ever reach it again. And this is not a handful of far galaxies. When astronomers do the arithmetic honestly, the answer is staggering and quiet at once, of all the galaxies we can see in the sky tonight. And there are perhaps 2 trillion of them scattered across the reachable universe. The overwhelming majority, more than 9 in every 10, are already past that line. Their ancient light is still arriving, so we can still see them glowing where they were billions of years ago. But they themselves have already been carried by the swelling of space beyond any possible reach. If we launched a ship toward them today at the very speed of light, it would never, ever arrive. They are visible and unreachable at the same time, like starlight from a candle that was blown out before you were born. The majority of the galaxies we can see tonight are already gone from us in every way that matters, and the space between us widens every second you lie here breathing. Up at the end is not a climb, it is a direction full of things that leave, and even the ones still within reach are barely within reach in any human sense. Our nearest large neighbour, the Andromeda Galaxy, the one bright smudge you can still see with your own eyes on a dark night, the farthest thing any human can see unaided, is 2.5 million light-years away. Its light left on its journey to your eye before our earliest human ancestors had learned to make fire. To send a ship there at Voyager's speed would take not thousands, not millions, but tens of billions of years, longer than the universe has so far existed. Even at the full speed of light, the crossing would take 2.5 million years. That is the nearest large galaxy, the closest possible destination up and out. Everything beyond it only grows more impossible until the impossibility becomes absolute at the horizon we just described. And there is one last turn of this, a slow and lonely one, waiting far in the future. Because the expansion never stops, the galaxies will keep fleeing, and the horizon will keep swallowing them, one by one, over the coming billions of years. Far enough ahead, long after our sun has died, the sky will empty. Every other galaxy will have crossed the line and vanished from view, their light stretched away into nothing. A living thing on some world in that distant age, looking up, would see only the stars of its own galaxy, and, beyond them, perfect blackness. No other galaxies, no evidence that they ever existed. No way to know the universe was ever anything but one lonely island in an endless dark. They would have no way to discover the truth we can still read tonight. Which means this moment, our brief age, when the sky is still full of 2 trillion galaxies and their ancient light still reaches us, is a rare and precious window. A short chapter early in the universe's life when it is still possible to look up and see how vast everything truly is. We were born in time to see it. That too is a kind of gift, and we'll come back to it before the night is over. So we have gone all the way. From the grains of dust in your inner ear that told you which way the floor is, up through the falling circle of orbit, up the deep well of the sun, up out of the flat plate of the planets, up past the wall of the bubble, up through the frozen shell that reaches almost to the next star, up out of the great wheel of the galaxy, a climb we cannot even begin, and up at last into a dark where the destinations themselves flee faster than light. Every rung was higher and stranger and more impossible than the last, and at the very top we find not a summit, not an edge, not a place to finally stand and look down. We find that there was never a top at all. There was never an up. Let me tell you what that means. Chapter 9. There is no up. There never was. Follow it back down now, gently, all the way, and see the whole shape of it at once. The up you trusted when the night began pointed away from the centre of the earth. But the earth is falling around the sun, so that up is not fixed. It swings in a great circle through the year, pointing a different way in summer than in winter. So you climbed to the sun and made the sun your centre and called up the direction away from it. But the sun is falling around the galaxy, so that up too swings, a slow circle 230 million years around. So you climbed to the centre of the galaxy and called up the direction out of its wheel. But the galaxy is falling through the local group, and the local group is adrift in an expanding universe that has no centre anywhere, no middle, no heart, no place that all the rest turns around. There is nothing left to point away from. You have run out of centres. And when the centres run out, up runs out with them, because up was never anything but the direction away from whatever was holding you. That is the quiet truth at the top of the ladder. Up is not a place in the universe. It never was. It is not woven into space. If you drifted in the true dark between the galaxies, far from every world and every star, and someone asked you to point up, you could not do it. There would be no answer. Not because you'd forgotten, but because the question would have no meaning. Up is not out there. Up was only ever the shape of being held, the direction that gravity, some particular gravity, some particular loving pull, was reaching from. Take away the thing that holds you, and up doesn't become hard to find. It simply stops existing. Think of a compass. A compass needle finds north because the whole earth is a magnet, and the needle feels it and turns and points. There is a real direction out there for it to find. Now imagine a needle that could point up, truly up, cosmic up. There is no such needle, and there could never be one, anywhere in the universe, because there is nothing for it to feel. The universe was never magnetized toward a top. No force runs that way. No arrow is hidden in the empty space between the galaxies waiting to be found. Every builder of every instrument, on every world that has ever held a curious mind, would fail at the same task in the same way, not for lack of skill, but because the thing itself was never there to detect. Down we can always find, wherever there is something heavy nearby. But up, alone, unattached to any mass, is the one direction no compass in all of creation could ever be built to point. Every up you have ever known was borrowed. borrowed from the earth, which borrowed its pull from its own falling around the sun, which borrows it from the galaxy, which drifts uncentered through a universe that offers no direction to anyone. All of it borrowed, none of it owned. The child throwing the stone, the astronaut falling in her endless circle, the voyagers coasting up a well 30,000 years deep. You, tonight, certain of where the ceiling is, all of us pointing confidently at an up that was never there, that was only the tender fact of something larger holding us in place. And that could be a cold thought. For most of tonight it has been the engine of dread, the price rising, the wall growing, the destinations fleeing, the sense that we are small things trapped at the bottom of well, inside well, inside well, unable to climb out, unable to even name the top. If we stopped here, that is what you would carry into sleep. But we are not going to stop here, because the same fact that took up away is, when you turn it over in the dark, one of the most quietly comforting things the universe has ever offered. Let me turn it over for you now, slowly, as the night comes down. Chapter 10. Held. You cannot go up. Not really. We have spent the whole night proving it, rung by rung, and it is true. But listen to what that actually means, underneath the dread, when you let the fear settle out of it like sediment in still water. It means you are held. Every up we chased tonight was the direction away from something that was holding us, and we could not escape any of them. Not the earth, not the sun, not the galaxy, because their grip is deep and faithful and does not let go. We called that a well, a trap, a wall. But turn it over. The earth's pull that you cannot escape is the same pull that keeps you from drifting off the surface into the killing cold, the same pull that holds the air against the ground so you can breathe, that holds the ocean in its basin, that gave your inner ear its grains of dust and your body its sense of which way is home. The sun's deep well that no probe can climb out of is the same grip that has held the earth at exactly the right distance for 4.5 billion years, circling, never falling in, never flung away, long enough for oceans to form and life to begin and, eventually, for you. The galaxy's impossible pull is the same embrace that has kept the sun from wandering off alone into the dark, that gathered the gas that became the sun in the first place, that holds 200 billion stars together in one turning wheel so that nights like this one are even possible. You are not trapped at the bottom of all these wells. You are cradled at the centre of all these arms, nested inside them, one within another, held by the earth, which is held by the sun, which is held by the galaxy, which drifts with its small family of galaxies through the endless dark, all of it holding you right now, exactly where you are, so that you do not have to fall. You were never meant to climb out. You were meant to be here, held, carried, kept. A small warm point of awareness inside a great nested embrace that reaches all the way up past every rung we counted tonight. Remember too what we found waiting at the very top of the ladder, that in the far future the sky will empty, the galaxies will slip away one by one, and any mind alive in that distant age will look up into a darkness that tells it nothing. And then remember where you are lying tonight. You are here in the rare, bright, early morning of the universe, when the sky is still full. 2 trillion galaxies still glowing overhead, their ancient light still finding your window. The whole vast structure of everything still readable to anyone who cares to look up and wonder. You cannot go up to them. That is true, and we have spent the whole night making peace with it. But you can see them. You were born into the one short chapter when they are still visible, still knowable, still able to fill a quiet mind with awe. You didn't get the direction, but you got the view. And the view was always the better gift, because you can hold it while lying perfectly still, held by the earth, going nowhere at all. And there is one more gift in it, the last one before you sleep. Because you, lying there, are the only part of all of this that knows. The earth does not know it holds you. The sun does not know it has carried the earth around 200 million year circles. The galaxy turns without a single thought. But you can lie in the dark and feel the whole nested weight of it, and understand it, and be moved by it. In all that vast machinery of falling and holding, of borrowed directions and impossible climbs, you are the place where it becomes aware of itself. You are the universe, held in its own arms, quietly noticing that it is held. That is not a small thing. Out of all the directions that turned out not to exist, that one, the turning inward, the noticing, might be the only direction that was ever real. So let go of up tonight. You don't need it. You never owned it. No one ever did. Up, down, out, away, every direction we've ever trusted, all of it borrowed, none of it kept. Let it dissolve, the way it dissolves out there in the true dark, and feel instead the only thing that was ever solid, the holding. The earth beneath you, faithful, the sun beyond it, faithful, the galaxy around it all, turning slow and patient and sure. You are exactly where the whole universe has arranged, across billions of years, for you to be. Held, carried home, there is nowhere you need to climb tonight. There is nowhere up to go, and nothing up there waiting. There is only this, the warm, small miracle of being held by something so large it has no top, and being, for this one quiet moment, the part of it that knows. Rest now, you are not falling. You are being carried. Good night, and may your dreams drift gently among the stars, knowing that whatever holds them holds you too. This has been Interstellar Nights. Sleep well.